Hello everyone, in this lecture we are going to introduce an expression for the x bar of quarter of a circle. For the x bar we have to use a vertical strip. We have x and y axis, and this is a quarter of the circle, and the vertical strip having width of dx by y, and for the point xy can be expressed as x equal to r cosine theta and y equal to r sine theta, where r is the radius of this quarter of a circle. This time we need to have an expression of dA multiplied in x for the first moment of area. What about the first term dA? The first term dA for the strip is equal to r sine theta dx, where is r sine theta is the y, because the area of the strip, as we remember, is dx by y. Y expressed in terms of theta will be r sine theta multiplied in dx, so this is a term of dA. About the term of the x is r cosine theta. In order to substitute for dx, we have to integrate, differentiate, for the x, and the differentiation of x in order to get dx is equal minus r sine theta. We multiply all the three items together. We are coming that we have a sine multiplied by sine multiplied by cosine. So for dA multiplied by x is equal to the minus r squared sine squared theta by cosine theta d theta. Make integration of dAx. We get the minus r squared outside the integration, and again we are integrating from pi over 2 to theta equal to 0 of sine square theta by cosine theta d theta. For sine theta, cosine theta, it will remind us of sine 2 theta, but we need 2. That's why we are multiplying 2 and divide by 2. Minus 2 over 2 r squared integration of sine theta, we take it out. One of the sine square we take it out, and we put inside parentheses sine theta cosine theta d theta. So we have minus r squared over 2, and the 2 sine theta cosine theta will let it inside the parentheses and multiplied by sine theta. We reach to minus r squared over 2 by sine theta multiplied in sine 2 theta d theta. But we have an expression that if you have two angles, sine alpha, sine beta, we can say that sine alpha, sine beta equal to 1/2 cosine alpha minus beta minus cosine alpha plus beta, whereas alpha in this case will be equal to 2 theta, while the beta equal to theta. By applying this formula, we have minus r squared over 2, which is multiplied in the integration from pi over 2 to 0. 1/2 cosine alpha minus beta will be cosine theta, minus cosine alpha plus beta will be 3 theta, all multiplied in d theta. We take 1/2 out, so we have minus r squared divided by 4, multiplying the integration from pi over 2 to 0 of cosine theta d theta minus cosine 3 theta d theta. The result of the integration for the cosine theta is sine theta from pi over 2 to 0 minus sine 3 theta divided by 3 from pi over 2 to 0. So we have minus r squared over 4, open parentheses. We have sine 0 minus sine pi over 2, which means we have 0 minus 1. And we have this minus sign again, open parentheses. We have sine 0 minus sine 3 pi over 3. Sine 3 pi over 2 divided by 3 will give us negative value of minus 1 over 3. And again, don't forget that we have a minus sign. So at the end we have minus r squared over 4, open parentheses, minus 1, minus minus minus, we have 1 minus, and we have 1/3. Minus 1 plus minus 1 over 3 will lead us to minus 4 over 3, multiplied in minus r squared over 4. We will get our expression at the end that ax bar which is the first moment of area, about y-axis will be r squared over 3. In order to get the x bar, we have to divide the ax bar over a, which is r to the power of 3 over 3, divided by the area which we have obtained earlier. Then we have by r squared over 4. 4 will come up, and we have still capital R divided by 3 pi. This is the expression that the x bar from the CG to the y-axis would be 4 capital R over 3 pi. Next task will be try to determine the y bar of the quarter of the circle, which is supposed to be also equal to 4 capital R over 3 pi, since the CG will lies on line of symmetry. Thanks a lot and see you in the next lecture. Goodbye and take care.